Okay, my name is Gilles from the Insights company, and I will present you our research about GaN-on-Porous silicon for RF application. This is the result of our research and it's a collaboration between the Insights, the research center EuMIC, and partner, academic partner UC Louvain, VIB, and HEPL. Okay, in GaN on silicon technology, we use Ender substrate, and we grow above it some layer between a mixture between aluminum nitride and gallium nitride, and we mix to have the good properties for the application. For RF application, we use a high resistive silicon to avoid some RF losses. The problem is during the fabrication, there are interdiffusion between the atom, between the layer, and for example, there are aluminum atom diffused into the high resistive silicon substrate. With this aluminum silicon nitride, with the diffusion of the aluminum in the high resistive silicon, the silicon becomes very low resistive, and then the electric circuit see a low resistive and not a high resistive silicon, and the circuits are subject to the RF losses. To avoid that, we propose here a post-fab porosification. Then, porosification is transfer the Ender substrate into a sponge with nanopores, the holes with very low, very thin diameter between a few nanometers, and then we do that after the fabrication of the circuit. Then, after the fab, to avoid problem with the porosification before in the fab process, we do that after the fab, and we make the porosification by the back side up to the front side, up to the buffer. Like this, we are transparent for the fab. The front side circuits are not affected, and we use a very simple and cost-effective porosification. It's possible also to make a localization of the porous silicon to make the porosification just below the area of interest. Okay, let's talk about the result. Here we are the result we use for the first time just aluminum nitride on porous silicon. We compare with substrate with island on HAir to compare with typical substrate in the industry. The typical substrate is in red, and our technology is in green. And we can see for all the parameters, the properties are improved. For example, insertion loss are significantly reduced. The effective resistivity is kept at a high level, and the relative permittivity is divided by 3. For the large signal, for the linearity, for example, we can see a very great reduce of the linearity, of the problem of the linearity. For example, here we can see in green, the second harmonic is below of 65 dB from the first harmonic. And also, the linearity in terms of thermal stability is very good. We do that also on GaN-on-Porous silicon with full stack of GaN technology, and we can see here the result is pretty the same that on the ALN on porous silicon. Then we can conclude that the porosification of the Ender substrate can improve the properties of the substrate for the RF application. Thank you.